morning, everyone. Very happy to see you here today. Hope this lecture will be interesting for you. I think that the lecture will be kind of a bit more relaxing and cheerful, maybe. Yeah, because we're going to talk about the industry and about more business material things and how to implement all the scientific and research investigations to the real business and how to make money, how to earn money using everything that we are studying here. Okay, so yeah, let's start with introducing.
I'm sorry, I would like to have some interaction,
Okay.
if you don't mind. I'm really interested and curious about like the proportion of you who are mostly about research and others who about like industrial developing, production developing. May I ask you, show of hands, who like totally about research? That's nice. It seems like to be a half. And may I also ask you to also show your hands who about industry development, working in company and earning money for them? Less, but that's okay. And I hope you surely, I guess, it will be helpful what we are going to say for you, but for guys who are research or for guys who are like seeking themselves where to work, it also will be helpful.
I'm actually absolutely sure that it will be helpful because when you do any kind of research paper, there is a part of innovation, yeah, and you have to explain why your work is useful for the world. So yeah. Okay, so let's start with the introduction a bit. There is a lot of letters on the slide. Mostly what we have to say is...
don't read them, we will tell you short.
We work at Alpha Bank together. Dani works with all the NLP models for the chatbots, right? Yeah, and I work for all the models for the assistants, development virtual assistants for the real management. So kind of like co-pilots. Yeah. Hello, guys. Okay, we also have to tell you a couple of words about the bank where we work, and I think that
and actually a little bit about Russian fintech market at all.
Yeah, fintech market at all, yeah. Okay.
Yeah, I can continue here with an overview of agenda, but actually we will going, me and Daria tell separate lectures, but now it's like a general part, introduction. Yeah, thank you. Yeah, here is some actually, I guess, interesting statistics general about Russian fintech market, not about our bank or any other bank. So I will just read if you don't mind. So it was interesting for me before I prepared this presentation to also know this. So 90% percent is the internet penetration rate. So in Russia, it's really popular to use banking apps in a daily basis. Also, like 3 cards per person, so we don't use like one in one bank. We have many banks and use many cards, and also more products. Here is 5 products per person. Here is also, you can see the share of mobile banking users. It's almost 80%, which is, I guess, too much, and it shows how it's integrated in people's lives. And the last one is a share of cashless payments, which is also higher than 80%. Here you can see like some conclusions about it. It is good, like strong digital infrastructure that allows to process lots of transactions and allow people to use it like on a daily basis, as I already said. And I guess that's the main idea. Could continue. Yeah, here you can see the landscape of companies which somehow or mainly are part of a fintech market. I guess some of you good know these companies. Yeah, and Alpha Bank also is a part of this community.
Yeah, for our Chinese friends, I think we should say that the banking sphere in Russia actually differs from what we have seen in China. We have different habits in paying and using bank products in Russia. Here I've seen that you mostly pay with WeChat or Alipay. In Russia we don't have one super app. we have different banks products, and actually usually we pay with cards, like the plastic cards itself, or with a lot of new methods to pay. For example, we have a lot of NFC stickers, so you can pay just with the phone, with a sticker, or even with a biometric information. Just you can just smile, and and the money will be lost from not lost, yeah, but will be paid from your bank account. I think that's kind of cool, and actually very different from the experience that we have here in China. All these differences are quite curious. Okay.
Yeah, a few words about Alpha Bank, bank we are working in. I think like the main part is that it's the biggest commercial bank in our country. It's like strong claim, strong sales. It's in the market for 35 years, and it's like positioned as an universal bank. Here is also some statistics, but I'm not going to tell each point. You can read it by yourselves. Yeah, and here is like interesting thing. We passed a long way as a company in terms of understanding of ML and making it's a process of developing huge amount of models for different purposes. And here are some facts that we have for now at this moment more than 650 models in production. Again, at that moment, so it's working now. And we have also a huge department who develop new models and maintain old models, maintain and improve them. Our department now considered more than 300 data scientists, but actually it's not just data scientists or ML engineers, it also A/B testing team, monitoring team, data engineers, machine learning engineers, and so on. Actually, I will tell you a little bit more in my part of lecture. Yeah, in this, here is few words about infrastructure that supports such amount of models, our zoo models. Here is the stability rate, which is almost 100%. We are going to like even improve this number, but it's still like impressive and good. And just fun facts, despite, as we already said, me and Daria working on NLP models, here is a huge amount of just classic ML models, and the amount of features powered set models was more than 40,000. Yeah, about technologies, it's interesting slide. For sure, you know about GNE hype. We also invest some time in developing it. To be honest, mostly it's not about financial profits and stuff like that. It's a really important point, but we consider it's like strategical investment. When the technology would be like cheaper, we could like make it maybe in positive cash flow. Also, many models for now working and powered by AutoML, so it's developed with our data scientists. So we have like an infrastructure that allows us to like just push a button, and AutoML will develop the baseline. NLP, that I already said, some computer vision, but actually mostly OCR, OCR documents, passports, and so on. And as I already said, high load infrastructure that powers the models. Yeah, actually, we decided to like switch. So the first part of the lecture would be Daria's, which is RAG evaluation.
Thank you so much for introduction. Yeah, I'm going to start my part about RAG. Actually, I think that's quite a relaxing topic because RAG is a well-known topic actually. Yeah, and today we're going to make a philosophical discussion about what is a good RAG and what is a good RAG in an industry. How can you measure it? This lecture can be useful if you're ever going to switch into an industry and going to become a DS team lead or any kind of management role, probably. But also, it's useful for just developers because it will help you to create really good RAG pipelines and solve real-life tasks with a good quality. So let's begin. Okay, so let's start with quite an easy question. What is a RAG? Everyone knows what is RAG, I'm sure. Yeah, but we have to be the same page. So I will just explain my point of view on this topic. I have heard many definitions of RAG, especially when I had job interviews to my team. People say different things. Sometimes people say that RAG is a way of fine-tuning, which I personally disagree. Sometimes people say that it's just a way of smart prompting, which I personally agree. And sometimes people say that RAG is sort of a model ensemble, which I personally also agree, sometimes, but not always. Okay, so we usually have two main parts in RAG. The first one is a retrieval part, of course. And for me personally, I believe that that's mathematically is a task of multitask classification and sometimes ranking. The part of ranking actually is not always mandatory. Yeah, you can use just multi-classification task, yeah, and you will find all the chunks, all the parts of the information that you need for the prompting. And the second part is exactly the generation with the prompting. But I think that we should look at the RAG separately, because in real life you can use both parts actually separately. Sometimes it's convenient to use just the retrieval part. And also, I have heard that the RAG is a thing that is used to make the answers for users' questions more reliable, which I actually also don't agree. Why? Because you don't always have to have the questions. Sometimes you can use the RAG pipeline to work with different type of tasks. Sometimes the user query can be not only a question, but also, for example, a part of a dialogue which you provide, and you want to have a hint for that dialogue, or actually any other part of queries, which are the exact task for the LLMs. So you prompt the LLMs to do the exact task. For example, you want them to create kind of sales arguments, right? It has nothing to do with any questions or user's query, yeah? But you also want to provide some specific information which is retrieved by the part of a RAG pipeline, okay? So let's stop here with saying that RAG is a smart way of prompting LLMs, and this part of prompting, yeah, of searching the exact good parts for your prompt is a retrieval part. And to create a good RAG, we have to actually evaluate the RAG pipeline in general, but these two parts separately as well. Okay, and why do we actually need RAG? We have a lot of technologies. We can solve problems in very different ways. Or when and why do we need to use exactly these RAG pipelines? The first thing, actually, and the original thing, how the technology, yeah, how the paper about retrieval augmentation generation was developed, yeah, was written. It was about LLM hallucinations. We faced the problem about the hallucinations, and we've tried to solve it, and that's how the RAG was developed. The second thing is when you have some private documents. Sometimes you have ability, yeah? You can use really big models, so the problem of hallucination is not your problem, yeah? And the task probably is quite simple, but you have some private documents, it's quite a very often thing in industry, yeah? So you have no other choice but using RAG, okay? Because you have to be sure about privacy. Also, RAG is always useful when you have little data, because otherwise, if you have private documents and you have ability to use big models, it's easy for you to have them on your own machine. Actually, you always have money for that, right? And the first idea is that you can just fine-tune your model and use it, and that's it. But if you have little data, so yeah, you have no choice but using RAG. And also the last reason, but sometimes it's one of the most often reasons actually why you choose this exact technology for your task, is a frequent change of data. If you know that your not private data is changed almost like every day, for example, the product's definitions here, or I don't know, some documents, some instructions that are changed every day manually, you will have to use RAG because you cannot just every day retrain your model, yeah, refine tune it. Okay. And also let's talk about the reasons we need to measure the quality itself, yeah. Here they are listed one by one, but not in an order of importance. Okay, so first of all, I'm from business, and the first thing why I want to know the quality is because I want to measure business effect. And also I want to understand how my RAG pipeline meets the business requirements. These two tasks actually sound similar, but they are different. The first point, you have to know how much money you earn. And sometimes you can earn a lot of money, but it doesn't meet business requirements, okay? Sometimes business wanted to learn it in a to earn this money in different ways, and they will not be kind of satisfied with your model, okay? So you have to separate these two reasons and provide different information here, okay? And also, of course, we have to know the quality because we want to correct the pipeline mistakes, and that's the most interesting part for the developers, I suppose. We will talk about this mostly in my lecture later. And also, one more reason why it is important to know how to measure RAG quality if you work in an industry, because this will exactly help you to explain why you deserve the bonus and the raise of your salary. So yeah, you have to listen carefully if you're going to work in an industry. It will help you much. Okay. So, the three main criteria of a good RAG, we're going to talk about them precisely, but now let's just name them. The business effect, we're going to talk how to measure money. Engineer effectiveness, we're going to talk how to measure that SLA is met and infrastructure requirements are met and everything works good. And the technical quality itself. So, let's start with a good business effect. I think this part is the most far from everything that is connected to science. So I'm going to talk about it a little bit more in details. And so good business effect consists of several things. First of all, is that we actually can count profit. What does it mean? It means that before starting developing RAG pipeline or actually any kind of other models, and even before starting to solve the task that business brought to you, you have to know about the business process and to think how you can count the profit, how you can find the exact place in this business process where you can apply your model and it will give you some money or save some money. Yeah. So first of all, you have to think about this exact place part in the business process. Yeah, you should think that does it even exist theoretically? And sometimes a good business effect and a good model is the one that is not done. Sometimes a good decision is to say no, we're not going to do this model. We're going to do something else because there's no money there. Okay. The second part is that we can count costs. When you start to design the models or an ensemble of models for the exact task, you have to think about the way to count all the costs on data, infrastructure, and the time itself of work. And if you start talking about the task and you cannot understand how much data you're going to need to solve the task, what exactly will be the infrastructure, and how much time it's going to take, it's also better to say no to the task. Yeah, and actually, the good thing is only the situation when we can find the optimum between the cost and the quality, yeah, and the ratio should be positive, not negative, okay? And only in this case, we're going to even start working on a task. Otherwise, it's just useless, which is quite simple. Yep, but how actually we're going to measure that we even have this business effect? Okay, we theoretically can think about it when we're setting the task, but how in real life all these theoretical explorations sometimes don't meet the reality, and you have to measure it in real tests, and we usually use for that A/B tests, of course, because that's the only one statistically correct way to measure the effect and actually prove that it exists. Sometimes it can be impossible to even set up it because of the business processes that work in the industry, and you have to know it before starting doing any kind of tasks. You have to know how the business process works, and is it possible to set the test? And if it's not, you have to be careful about it and to talk to your to the people that want the model. Okay. Yeah. And the best practice is to design the A/B test even before you start developing anything. So please be careful, taking in mind. That's the best practice in the industry. Now let's talk about more technical things. Let's talk about testing speed and inference metrics. Yeah, that's all. It's quite easy. There are two ways to measure it. You can measure end-to-end, the whole pipeline, or you can measure all the parts separately. I mean, the parts of the rack pipeline, all this chunking, search engine, ranker, LLM, and all of the parts. Okay. Of course, the best way to measure is to measure end-to-end. It gives you more correct numbers, but sometimes it's not always possible due to some infrastructure curiosities. So the second method also works, but you just have to be a bit careful about it. And you should remember 4 things. First of all, infrastructure setup. I know it's obvious, but that's the most popular mistake when you create any kind of measurement in industry. That's the setup in test and setup in production is different, or some parts are different, and the numbers just, they don't correlate because of that. Also, be careful about LLM leaderboards. Sometimes you would like to use some numbers from there, yeah, just not to measure the exact performance of the LLM on your own machine, but to use the numbers from there. You should be careful about looking at the infrastructure setup that they have used while measuring the numbers in the leaderboards. Yeah, and also be careful about the leaderboards itself. They differ. Yeah. Also, take in mind the LLM optimization that you have done. They also can be used in the leaderboards. So this setup, it also should be in your mind. And I think the most attention should be drawn to the test data set. I understand that's obvious, but still I have to tell it. The test data set that you use to measure the speed and inference metrics should be exact as the data that is going to be in the production. Yeah. So the same length of the input queries, the same number, the same RPS, and so on and so forth. Just be careful about it. Okay. And finally, yeah, the technical metrics. We're going to measure every part of the pipeline. Sorry. Yeah. So to know the quality of the pipeline and to know where exactly is the problem and where is the mistake and how you can correct it, of course you have to cover all the pipeline with the metrics. There's nothing new I'm going to tell you about the the metrics of RAG pipelines, but still let's kind of make it systematic. Yeah. First of all, we have to think about the metrics and the combination of the metrics in a way that we want to know where is the mistake and how can we find it if we have the full set of metrics. First of all, the first part where everything can be broken is the chunking part. Usually, it gives you the biggest raise of the metrics of quality overall in the pipeline. So yeah, what we should measure here, we should measure whether the overlap is correct. It can be too big, it can be too small, it can be irrelevant at all. Yeah, we have to measure whether the overlap that we have chosen is correct. Also, we should measure the amount of meaning in the chunk. That's the way how we can understand whether the chunk is good or bad. The good chunk, actually, from my point of view, is the one that consists one exact kind of part of information, and consists exact part of information and doesn't consist other parts of information, because otherwise it will spoil the whole information for the LLM. Also, the problem that can occur in the chunks is outdated data. You have to think about the ways that you can find out that your data is not correct and it just outdated. It just doesn't consist the relevant information anymore, but it's in your chunks already. And the fourth problem is mislabeling. Sometimes in chunks we also use tags and labels, and they can be incorrect. And you also have to know how to deal with that, right? The ideas that I can say, that I can use trying to find out these mistakes, and that we actually use in our job. For finding the mistakes in overlap, we actually use some labeling data, and we're trying to find out whether the length of chunks that are labeled by the real people is the same as the length of chunk in our database. Okay. The amount of meaning in the chunk can be measured by any kind of metrics that are connected with the semantics. Outdated data, actually, this is a tricky thing. The easiest way is to say that, okay, we're going to use the labeling again, but it's quite expensive. So sometimes we create some filters for the facts, for the exact numbers that are changing constantly, and then we use these filters to filter our chunks every day, just to have an alert every time we understand that the numbers have changed and the facts have changed in the chunks. So we need to do rechunking probably. Okay, and mislabeling, unfortunately, is the most difficult part, and you can find out it only by relabeling it again with the human. Okay, the next thing that can be broken is embedder in search engine. Here are the classic metrics for this part. I personally work with precision recall and fmeasure for this exact part. I meet a lot of people who prefer using accuracy here. I personally hate this metric. I think it's one of the most kind kind of useless because the situations where it actually shows anything are so rare. You have to have this balanced data set. It usually never happens. So yeah, it's better to use some metrics that are resistant to imbalancing in your data set. So this, I actually don't think that we have to spend much time here. It's quite obvious. Okay, for the re-ranker part, of course, we use MRR and NDCG. These are also classic metrics for re-ranking. What is important here, sometimes we actually don't even want to optimize these exact metrics, because sometimes for us it's not important, it's not that important to have the most relevant chunks in the first place. Sometimes if we have a big number of k, if we have a lot of chunks in the prompt, yeah, we can face the problem of catastrophic forgetting, and it's more important for us not to have the relevant chunks in the middle, because in that case the chunks will be forget by the LLM, and it will cause lower quality to the whole RAG pipeline. And sometimes we want to optimize this metric in the way that the most relevant chunks are in the first positions or in the last positions, but not in the middle. So sometimes we just redo the formula and penalize the metrics by setting the relevant chunks in the middle. Okay, bless you. And also the generations metrics. Here are a lot of metrics. You can find them in Ragas, you can find them actually anywhere, and you can find them in Common Sense. Personally, in my practice, all these metrics here are just some examples from Ragas, the names of the metrics, but personally, in my experience, I create them every time for every new task, because they are usually connected to the business task. Sometimes for us, the quality of generation is connected with the hallucination. Sometimes it is connected with the coverage of the questions. Yeah. Sometimes we want the LLM to be able to say that it doesn't know the answer, and for us it's more important than all the hallucinations, all the correct answers, and so on and so forth. And every time we create the task, we measure the quality of generation in different ways. But the idea here is that you have to understand the exact business process that is led under the task. Because if you don't understand it, you will not be able to create to choose the correct technical metrics for the generation. The formulas are actually usually quite simple. So the main task is to understand what exactly is the quality in your exact task. Okay, what else is important in generation? These things are here just to be mentioned, actually. Yeah, so you have to think it's kind of like a list that you can go through and think whether it's relevant to your exact task. Yeah, but as I have already said, every RAG is unique, and you have to choose the metrics every time. And actually, the last thing I want to talk about is two main ideas on how we can measure the quality. The first one is the real human labeling, and the second one is LLM as a judge. Both methods are good. Both methods are used in different situations. Sometimes we combine them. And we have to think about these 5 ideas when we choose between these two methods. And the first one is, of course, reliability. We understand that the LLM as a judge is not that reliable as a real human labeling, but sometimes it's more reliable. Yeah, it depends on exact people who are going to label your data. If you have people who are professional in the field that are going to measure, of course we have to choose them. But sometimes, if you have people who are quite far away from the field, you're going to label, and you understand that your methodology is quite complex and difficult, it will be surprising, but LLMs will do your task better and faster. Also, don't forget about the overlap. It can be applied not only to human labeling, but also to LLM as a judge labeling. So just use several LLMs to be more sure about the result. Yeah, the confidence interval also comes together with the overlap, and cost and time. Sometimes, if the methodology is not that difficult, it's much faster to do it with people and even cheaper. Yeah. Okay, so these are quite obvious things, but I think it can be useful to talk about that in a systematic way. Hope it was useful for you. Thank you for your attention. We're going to continue with Dani lecture. Some questions? Okay, yeah, sure.
Thank you for your lecture. You mentioned that models leaderboardships are not that good to evaluate the quality of the model. So how do you select models to validate and then implement in your pipeline?
Thank you for your question. When I said that models leaderboards are not that good to be used to measure the quality, I meant that, of course, you can use it, but you have to be very, very careful. You have to look at the infrastructure setup that they used to measure, and you have to look at the sorry, I forgot the word in English. LLM optimization setup also, because there are so many details that can occur as a problem in your real RAG pipeline. Of course, we use LLM leaderboards to choose the models, but every time we choose several candidates of LLMs, and then we set up our own experiments with our own data, because actually the data in the leaderboards is good. Of course, they have good data sets, but it differs from the real life task and from real life data all the time. It's, you know, for people who work with science, for students who come, for example, to стажировка, what's the name for internship? Yeah, for internship to the company, they are always so surprised that the data is dirty. It's not so clean as in my university task. How can I work with that? And it usually is. So you have to measure it in real life.
Thank you. But besides accuracy metrics, what do you also count?
When we talk about the RAG, if we talk about RAG task, we in my team, I usually count recall, precision, F measure, and sometimes, but not always, I count MRR and NDCG if I use re-ranker. But to be honest, it's not a mandatory part in RAG pipelines in real life. Sometimes just searching engine is enough. You just don't use this re-ranker because you have high RPS and you can't allow yourself to use this re-ranker because it's too slow. Yeah, so sometimes these parts and these metrics are okay. So you just measure how good the multi-class classification is. And then we have generation metrics. And they, as I have already said, they depend on the tasks. Sometimes what I measure, for example, I have a task where it is important not to answer if we don't know the answer. So it's important not just stop the hallucination, but to measure the ability of the LLM to say, I don't know. And the main metric there is, of course, recall on this exact task. This is how we measure the LLM generation. This is how we choose, for example, the model for this exact task, just in the very beginning. Sometimes it's important for us to be precise at all the information that should be mentioned for the client. And then, of course, we measure something like correctness, yeah, of the generation. And we just say that correctness is that all the facts that should be mentioned in the answer, they are mentioned, and if not, then it's 0. Okay, so every time it's a different thing.
Okay, thank you.
Thank you for your question. Any other questions, guys? Oh.
Okay. Thank you for your talk. And my question is, what is your personal take on explicit user feedback? I mean, like farms, for example, up or down, and does it actually help evaluate RAG pipeline, or it's too nosy and biased to be useful?
Oh, that's a wonderful question. Thank you so much. It's a good idea, but then you start to implement it in real life and you have you have so many problems. In my product, where I work personally, we have these thumbs up and down, and we don't use it to have any feedback on the models. We actually don't even use it to count the business metrics, because there was the idea that we can count the model effectiveness, yeah, and usefulness, but it's so noisy. People use it in such different ways. Sometimes they can be angry with the answer because the answer can be okay, but for example, it was too long or something else, yeah, or they are just angry with the question from the user, and they put you this thumb down. Or sometimes they put the thumb up every time they use the hint, for example. So yeah, that's extremely noisy. It's very difficult to set up the UX in a good way, in such way that it can be used later in training. Yeah, unfortunately. Yeah. Yeah, sure.
I guess we have enough time. I would like to tell a story about one project answering your question. I guess a year ago, we developed a summarization tool for operators in our call center. So to let them not search information like title by title, but a short summary that helps to shorter answer client's query. And we wanted to have feedback. Is it good or bad to improve our models? And amount of feedback was really small. And our heads decided to set a task to our operators that you have to. And actually, it was a metric like 60% of your like summarization activations has to have some up or some down. And this story finished with a thing that most of reactions was thumbs down because they hated that that was a task from heads that you have to put finger up or finger down. So it's tricky.
Yeah, that's extremely tricky, and yeah, you have to do a good UX design, and then you also have to work with people who work with that. People don't like when they obliged to do things. People, that's a secret, but people don't like AI. They don't like to use it in real life, and sometimes they just put you this thumbs down because they just, okay, I don't want to use it in my work, but I am made to do it. So yeah, very noisy thing.
It's like so much stories about please give me communication with person, not with chatbot, and yeah, it's really, yeah.
A lot of the things are in chatbots that work with real clients, but It's even worse in co-pilots that work with the managers in bank, because people actually understand that this thing is made to optimize the costs, and they don't like the idea itself, of course. Yeah, and actually people just don't like changes sometimes. That's why.
Yeah.
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 Thank you for your question. That's our personal pain.
Yeah. I see. Yeah. Thank you so much.
Okay, there is another, I suppose, tricky question on how do you measure like costs, time, and okay, what do you mean kind of? How much would it depend on kind of specific way of deployment LLMs, and what kind of KPIs you can state here?
Yeah, that's the second tricky question. um, it all depends. It all depends on the setup. It all depends, actually, usually depends not on technical setup, but on a business setup. Because in big companies, you...
Don't pay attention.
Okay, okay.
Just for students outside this room.
Okay, okay. So the idea is that sometimes in big companies, usually in big companies, you don't have ability to use any outside LLMs, any API LLMs. So everything is inside the company's privacy contour. And you have your own GPUs, a lot of them. And in good world, you would like to exactly measure, yeah, how much compute you use to solve the exact task. You just take the GPU, you set up the test with the exact RPS, and for example, you can do it for, you can measure for how many seconds the GPU is taken, and then you can have the cost of this GPU, and you can separate this cost of GPU per second, for example, yeah, and use that as a measure of how much money it exactly costs to inference your model. But in real life, in real corporate life, it all starts with budgets and with the exact. There are many budgets, and different costs are covered from different budgets. So sometimes the GPU can be free to you because it's from the proper budget, or from the budget that it's kind of like infinite, or from the budget that have paid for the GPU once, and now it's not convenient for the manager who run the budget to recount the costs. Yeah? But talking about like good economics and a good way to measure the cost that we actually use when we count the, how to say it, if it's efficient even to create the model, we take the cost of a GPU, a whole cost of GPU, and then we count that, for example, our model will use the whole GPU for the project, counting the RPS, and then we say that this cost of the GPU itself, for example, 10 millions, yeah, it just included in the decision. And then we count if we're going to create this exact model, we're going to implement it in the production lane. When are we going to have the profit that will cover all this cost of this one GPU? Yeah, like this. Have I answered?
Yes, in a way, but do you have another comment here?
If you don't mind, Dar. Yeah, I will go again. Yeah, sure. Thank you. Was your question about like GPU costs, or it's about in general about profits and costs, Alexei?
Can you repeat, sorry?
Yeah, was
Yeah.
your question about like costs on GPU in terms of LLMs or RAG, or it was like a general question about profits and costs and how we measure it and
Actually, my first question was about like cost of GPUs, kind of, and how do you measure, kind of, yes, kind of. It's not about like budget allocation, but more about kind of how do you specifically measure how much time it takes to deploy and how kind of maybe
Okay, I got it.
optimize these things.
So I thought it was like a second part, and I will tell a little bit in my part of lecture.
The short answer is we have a very huge time to market process document that actually covers all the process of development of the models. And we measure the time via this process document and via Jira as well. Yeah, so yeah. Product placement, yeah. Okay. Do you have any other questions?
Yes, I actually have a second related question.
Okay.
If you're talking about the costs, it's also about not only like the money spent, but also the satisfaction of customers, because typically if you have kind of longer wait time to kind of to a response, I don't know, by an LLM, by kind of decision for credit support or not supported, then it affects like NPS. And do you measure this correlation inside, and kind of how do you approach this kind of connection between business metric NPS, like Net Promoter Score, or something similar, and your kind of time to decision, time to create a response?
Yes, thank you for your question. Of course, we measure that. Actually, just yesterday evening, I had the conversation with my business analytic about the tree of the metrics. Yeah. I will tell you about my project and my product. We create the copilots for the operators that work with the client's feedback and client questions. And what we measure, the main business metric that counts to money is average time for answer, yeah, and we are going to minimize it. But also we measure the amount of automatization. That's the metric that shows how many clients scenarios are covered with agents and chatbots and so on and so forth. But also we measure, of course, in Alpha Bank we call it VOC. That's the metric that shows the satisfaction of clients. And where we set the aim not to lower it down, yeah, just to leave it stable. But also one more metric of quality is the number of sessions that are closed within one interaction. And I will explain now why it is important. Just imagine that you have implemented several models, and they now answer to clients much faster, for example, like twice faster. But they don't actually help to solve the problem, but they close the session with the client. Or, for example, they answer the question, but they don't know the details, and client is satisfied right now because he thinks that he has the answer. But in a couple of hours, he understands that he has more questions, more details, and he comes back with these exact question. So we measure the number of such sessions, and we actually want to minimize them, or at least not to maximize them. Yeah.
Okay, thank you. No more questions from me.
Okay, thank you so much.
Okay, thank you a lot. Okay, and we go to a second.
I prefer that. Thank you. Yeah, so hello again, guys. Actually, before I start a presentation, I would like to speak about some lyrics and disclaimer. Daria already spoke about some interesting things close to production and companies development rather than research. Actually, here is the name of my part of presentation, which is kind of playful, tricky, that ML is not just a model. And it could be considered as a set of like rules, ideas, maybe best practices, and maybe after I finish it, you will think that it sounds really simple, easy and clear, but believe me that actually it is. But I usually met speaking even if a senior data scientist, ML engineers, they don't follow all of those rules when they work again in a production development. So yeah, let's start. I will give you my vision of how to do well and how not to do bad. In here's a slide I wanted to divide it into with the question and the answer, but sorry guys, I didn't have time to do that. So let's imagine that it is. So the question is, let's imagine that we improved F1 score for model from 82% to 91%, and the question for you, so is it good or bad? But you see the answer. The answer, I hope, not hope, I guess that some of you might be answered that it's good. But if we translate this into like real case, the answer is a little bit different. So here is the case. Let's consider a fraud detection model. Yes, we improved the F1 score, and improved it like in a good way, but actually we, in terms of precision and recall, started catching fraud better, but 3 times frequently we started blocking good and normal payments, and actually it costs the bank a huge amount of money. So it's a good example when data like ML metrics seems to be that we are good, we are doing right, but translating into business, that we are not right. And here is the core idea developed by our designers is like warning image. So the crucial idea is that models metric, machine learning metrics, it's not the same as business metrics. And there's usually some transition between them. Sometimes it's not obvious transition, but it is. And for sure, I guess me and you love technologies, love doing like finding a better model, playing with hyperparameters to like find the best setup of, let's say, RAG pipeline or other. But this technology is not living like in isolation, except the research area. So it should be like considered and put it on a business interpretation. And until it helps people, the good metrics would give you nothing. Yeah, and such a situation I could call a metric tunnel vision, let's call it that way. So we over-focus on the metric itself and not thinking about what's the huge task in terms of like client's journey or a process we are solving to. Yeah, here is also an example that I usually met that a team spends a huge amount of time, even months, to improve some metrics for several percentage. But when you ask them a question, why you are doing this, they don't have a good like answer because like technology and like to improve the metric. Yeah, and here is like 3 ideas that higher metric is not equal to a better product, as we already saw at the first slide. The second, that a model is a means, not an end. So again, it should be considered as a part of something bigger, a process, a client journey, client experience, etc. And the last one is the real question comes first. So a little advice to you, for those of you who works in industrial area. So think about a model, not in isolation, but in general process. What's the problem you are trying to solve using this model? Yeah, let's move on. Here's another idea, really relative to like production development, that's notebook and model in Jupyter Notebook is totally not the same as a production-ready model deployed and used by users. For sure, notebooks are good to experimentation, but it's really huge gap between bringing the artifact of that notebook, the model, into the process. And there is, you can see at the slide, some differences. So working in notebook, it's usually about clean, fixed data set. As Daria already said, that interns that came into a company stuck about why my data is dirty, why it's not clean. It's about it. Yeah, sometimes metrics computed once by hand, yeah, and so on. But in production, it's much complicated. This data is not even sometimes dirty, but it's alive. It's shifting, it's drifting, and you always should consider it and update your model for these driftings. Yeah, also there is some things important that serving, versioning, and rollbacks, because if we deployed some bad model, we have an opportunity to fast rollback it, not bringing our customers a bad experience. This is a really important thing, this one. Continuous monitoring. In Notebook, there is no at all monitoring, but as I already said, to see these things, you have to somehow monitor it. And actually, we have a separate team, I guess, about for 10 people whose task is prepare BI's dashboards for monitoring each model that brings money. Yeah, that's it. Let's move on. Yeah, here is I wrote, let's say, anatomy of an ML product. So ML product is some value for a customer or user that's powered by ML technology. And as you can see, a model itself is just one part, one rectangle out of 5. So the first one is data. And actually, it's not about like collecting data set once a time. It's about an ETL process that constantly feed your model with the data. And in production areas, there is usually 2 types of, let's say, setups how model works. It's a batch setup and online. Batch is when you like collect data in some data warehouse, Hadoop, doesn't matter, and like launch it at a cron each day, for example. And online is like real-time models. It's also different ETL processes. One requires like Hadoop technologies, the other one requires, let's say, streaming like Kafka. The model itself, I won't stop here because I guess you know about models better than me. The third rectangle is interface and integration. So it's like a point when it's starting, it's wrapped as a service at first, and integrated in system when users after can connect and interact somehow with this model. Then decisions. Decisions is the step when the model somehow affected the users in some way, and then we collect feedback, and the cycle is closed. So it's like an always the process of improving model, and not always model, improving data pipelines, thinking about better integration and user experience, better like business integration, not technical, and so on and so on. Yeah, here is a small case study. Let's consider a recommender system that we developed and for example, Jupyter Notebook, doesn't matter, and it shows an offline accuracy of, let's say, even 100%. It's perfect, it's a really good model, but speaking about ML products, it's usual, not usual, but it sometimes happens in situations that you didn't think good in a way of how user will interact with that model. So even a perfect model, bad. So for example, let's say that we made a wrong decision and put the model into some into some tabs that's really opened by the users. And as a result, we have perfect model, as I told already, but it doesn't help the user and doesn't brings money to a company. And this case is aiming to say that this rectangle it's also very important to think about. And I guess it's mainly not about ML engineers to think about it, but I recommend all data scientists and ML engineers think a little bit wider, accept the model about the whole process and communicate with business colleagues. Yeah, here is an advice of a good way of thinking of what you are doing. And sometimes it's really my experience when I ask some of guys and maybe business staff what we are doing, they told me, let's train a model and see. Real case. Okay, that might be, but it's surely not the best way of how you could like creating new ideas and projects. And the good way is in a red rectangle. So it should be formulated in some measurable metrics. So if we predict some x and show it as equal to our user, then some metric m moves by n because and after because that should be a really like logical statement. And this statement is allow you to better understand what you are doing and how to do a model, because let's train a model and see. Usually it causes that you build a model, but after you find like lots corner cases when it's bad, and you should spend much more time to retrain it because like we didn't consider the business requirements normally at start. Yeah, also this advice is good, and also recommend you to start with cheap validation. So always start with some baseline. It also allows you to save some time, but bring a value by a model. And also when you start improving the model, maybe with other approaches, you will see the delta that brings you comparing with baseline. And sometimes this delta is not as good as the time, the cost time of data scientists. So it could be also tricky. Yeah, let's move on. Yeah, and here is, actually Dario already told about that. Here is the question: how do we know actually the model worked, the model within a process? And the answer is kind of clear. That's A/B tests. And actually, the topic of A/B tests, how to say, deserves actually much more than even one lecture about it, because there is a vanilla A/B test that's all of you know, but the world is much more complicated. And usually, speaking about vanilla A/B tests, we met the next situation. The team comes, we ask how much time do we need to like finish an A/B test, and they told us 6 months. 6 months is an appropriate answer because it's not, it's inappropriate for business. It's a lot, and there is also a nice area of A/B test mathematics that allows it to make it faster, make it much more faster. Yeah, so I guess you somehow know A/B tests, and I will like see the idea is kind of simple. You split the users and compare metrics. Yeah, shortly, here is a case when we, for example, deployed a model and see that conversion rate grows for 5%. And actually, the question is it rise? Is it rose because of the model or because of the other factors? And actually, sometimes it might be other factors. So it's a slide about that A/B test is what you must do. Yeah, and also it might seem when you listen a lecture about A/B tests, it's after the humanity invented it, the world became like the world with pony and unicorns, but it isn't, because in real practice there is some constraints, especially in the banking area. In banking area there is regulatory constraints that actually restricts what we can do with like splits and so on. Fairness and ethics is also an aspect that's important to consider, and small and sensitive populations, but here we can do with the things that I already told, it's some optimizations of A/B tests. Yeah, here is metrics I guess on the left side, all of you know what these metrics are. And again, I'm not I'm not saying that this metric shouldn't be considered. It must be considered, but also you must consider some transition from this to this. And here I can give you, for example, 2 examples in our company. I have 2 teams who develop chatbots. 2 teams because there are like 2 different technologies we use. So the first one is like scenario technology powered by like BERT models and LLM technologies that is powered by RAG and LLMs themselves. And crucial metric in chatbots is automation. Automation, it's easily calculated like in a technical manner, in that way. But we have also like a formula that allows us say how much increase of automations gives us amount of money. So we did an analysis that allows us to make the transition. That's the first case. And the second case, Daria a little bit told about it, is average time of an operator working with a client. As I told you, a year ago, we powered them with the summarization model. And that model allows us to reduce the amount of time spent processing a client. And we also, after like analysis, have a transition about how much of this time converted in how much money. Yeah. And here is other metrics that you also could consider. LTV, this metrics even modeled by our colleagues and used in decisions of giving them credit or not and so on. And also ranking the clients. Like revenue, NPS, also we discussed about it. Yeah, I guess I will skip this slide. This is about that you always balancing about like in terms of precision recall between these metrics and the right answer on a threshold when you have stop is actually like business impact. So it should be like you should give interpretation in technical manner, set with business colleagues and decide which is better to the client and the P&L. Yeah, fraud detection already discussed. It's the same. Credit scoring, I guess it's the same. I will shift it if you don't mind. Yeah, here's an important slide. I already told a concept of ML product, and as the title says, that ML is not just a model, ML product is not just an ML team. And here you can see the slide, and actually it's not all of them listed here, but participants of the development of ML products. So let's start with the first one, is business owner, also powered with analyzed. Here is that's a guy, a person who have a visionary about what to do and how to do. And my personal opinion is that ML team should be really like synced with these guys. Product managers that owning a backlog, prioritizing it, generating some ideas, also with business owner and data team. The data team itself, and actually here's not only machine learning engineers, but I will talk about it on the next slide. Designers, if we're speaking about like technology that we developed to our customers on a mobile app or a site, there must have be designers and actually UX team. I guess UX team is even more important because bad UI it's not nice, but it's not critical, but bad UX is critical. Legal and compliance, and as I already told, a monitoring team. Also, other rectangles might be a label team, A/B testing team, who also, yeah, I guess there is more, but it's the main part. Yeah, now we are zooming into a third rectangle here. Yeah, and who is ML engineer? It's a good question, and speaking with a cup of tea with our colleagues, we sometimes understand that we understand this term in a different manner. And ML engineer could be at least for this persons. The first is dev and researcher with the focus of experimenting and doing experiments. ML engineer, under ML engineer, we consider not also the guy who develops the model, but also who wrap it into a service. If we're speaking about like Python backend, it's like fast API app. ML ops, who are responsible for development, CI/CD, and delivering the model and the service to a production. And also, I not usually, but sometimes see that even data engineers also understood under ML engineer term, but it's different. This is the guys who are responsible to give these guys data in a good way. Data in a hypothesis step, but also data pipelines in a production step. Yeah, shortly on this slide, this is about banking specifics. What should we consider? There are like three very important things, and why very important? Because it restricts us in some decisions, so we must consider, because there is central bank who monitoring us and so on. So this is risk management, compliance, and security. And to be honest, this is like separate teams. And we also, in the start of some project, discuss them, some like restrictions, what we can do and what we cannot do. And I guess the last slide. Yeah, there is a summary. What I would happy if you like remember at least these 4 points. The first one is that a model is not a product. And as you already, I guess, understand, it's a huge gap that brings the model to become a product. The second idea is every technical metric has a price, and also it has a transition to a business metric that you also has to consider. The third thing is an ML product is built by a team. Again, project managers, product owners, data scientists, ML engineers, ML ops, data engineers, designs, and so on. And the last one is business meaning comes before code. Shortly, think then do, not otherwise. Actually, that's all. Thank you.
Okay, and you said a lot about different roles in the team, and basically it should somehow correlate with kind of experience, like okay, you have kind of a fresh graduate, like a master student, and how much time would it take to be kind of a good expert in one of these topics, like MLOps, for example? What's the typical estimate, and how this estimate maybe varies between different universities, for example, in Russia? Okay, you should, yeah.
Yeah, I guess now it's better.
No.
Yeah, speaking about ML roles, there are different skill sets, and actually, I guess I can say even mindsets. For example, devs and researchers, it's more about like experimenting. So it's more, how to say, творческое.
More what?
Творческое.
Творчество.
Сложно. Yeah, art.
Yeah,
it's more like an art of.
More like an art, yeah.
But rather talking about ML engineers, it's engineers. So it's closer to backend development because you're writing a service. So there is two different paths. One is like reading papers, knowing what is the thought and how to implement it somehow. The other is how to like made a high-load backend. Speaking about MLOps, it's totally different skill sets. It's about like technologies like Kubernetes, Jenkins, and data engineers. I guess you understand the idea. And the question was about what's the time. to become an
Yeah, yeah.
expert.
How much time do you need to become an expert data engineer? Like,
I don't even consider myself an expert, but I'm 8 years in industry, also developed lots of models.
okay, when you hire like kind of a senior data
A
engineer,
senior
how much years of experience you would expect?
I will answer exactly this question, but short lyrics. I consider what experience on the resume this person has, and it's the most important part for me. If I see some related experience to the task I wanted to hire a person to do, it's I could consider with a lower experience because it's more suitable for me than a person who has huge experience but a little bit different. And answering exactly your question, so senior engineers, I guess it's like 4+.
And okay, and how everything changed with LLMs like here? Do you experience that we have some shifts in terms how many people do you need?
It shifts in terms of vibe coding because ML engineers usually use this because their role is more like backend. Backend it's less art of work, and it's like determined of what to do and how to do, and this is why coding is good, and that's the way it changed already. Talking about data scientists, it's not vibe coding, but the LLMs helps in designing, for example, experiments and setups of how to do. So my opinion is that LLMs is not going to like kill these roles, but it will help in a different manner, as I already told. For some in ideas and and for others in like real code developed by a model. Did I answer it?
Yeah. Thank you a lot. And maybe the last question. Okay, you talked a lot about kind of different metrics about correlation between business and what you have in your model. How kind of this processes like progress in the company? Like you have a new bank, for example, and you kind of make first step there, and basically kind of you have, I don't know, two effects. Like if the company kind of is bigger, then typically the process is kind of more like bureaucracy to some kind of responsibility for decisions and kind of distribution of this responsibility. And on the other hand, the bigger companies, the more experience it has, kind of. How it relates to these tasks, and in what your opinion, kind of, is still some room to grow, like for alpha and for other bugs in Russia?
In this task, you mean like the whole cycle of development?
Yeah, kind of.
Yeah.
Like deployment of models, validation, like continuous validation.
Also, thank you. One of Rectangle is also validation team. Yeah. In huge companies, we have separate like audit function. Yeah. Let me think a little bit. As I told at the beginning, we have developed lots of models, and we have a zoo of 650 models. And one interpretation of this is that we have passed like a huge path, but the real side that's a lots of room of improvement, and this rules of improvement in like such huge manner, this in terms actually, to be honest, in a bureaucracy, in terms of how we formalize the process. Because there are many roles, to make them communicate efficient way, it has to be somehow formalized. When to go to this guys, when to go to this guys, and how the process looks like. We developed like a version 1 of such a document that regularizes this behavior, but there is still room in not also in development the document, but apply it in real life, because like it's also different things. Develop a document and live like it's written on the document. Speaking about small companies, I don't have so much experience, just a little bit in small companies. I guess their advantage is they're small in terms of they can fast like check hypotheses maybe on the final users, doing fast development, fast checking, and then if it's good, or we keep it. If it's not, we like thinking what to improve. And again, in terms of big companies, there has to be like a methodology. Did I answer it?
Yes. In a way, kind of. It's all.
Yeah, we can discuss if you want later.
Okay. Thank you. Any other questions?
Okay, thank you for your talk. And in your opinion, what is the most painful trade-off in industry and prod? I mean, metric, maybe accuracy or system latency or computational cost or something else. Maybe it's strict, but could you choose one?
What's the most like important?
Painful
Painful
trade-off, yeah.
painful trade-off is mostly about an accuracy in terms of my experience, because I'm working in a big company, and sometimes I hear like phrases like this. So do it good, don't thinking about resources. We'll give you resources. And doing good is the hardest part of this, even having much more resources. But I guess you understand that the all hype in LLMs, it's like the start of the path, but somehow it will be like, how to say, I guess people become somehow regret about like this overhype of technology, and this causes an necessity of thinking more about latency, because it's correlated with costs of resources. But for now, it's like, because we see as a strategical path, resources are seconds, quality is first.
Okay, and the second question about benchmarks. Do you use it actually? And like many experts say that offline benchmarks are useless for real world, and sometimes which in industry have run out of time, yeah, and we need to have to fast implement something. And do you have problems such that? And do you use benchmarks?
Yeah, I got it. Ambassador of this idea returned. Is your question about LLMs and RAG maybe specifically, or it's wider? Wider.
Yeah, wider.
For sure, we assessing the quality of each model. And as you know, I guess in NLP, sometimes the only way you can get the assessment is by label team with human. So we always measure it. And actually, when I told about monitoring data shifting and so on, also part of monitoring is the quality of the model when in a regular site, labelers assess production's answers. Yeah, so the answer is yes, but for each model, we think, I guess, separately of how to measure it in the correct way. So it's not like a general benchmark, but it's data set that we think reflects how the model works and will works online.
If you let me, I would like to add something. Talking about benchmark themselves, it depends on the task. Sometimes, as you have mentioned, we have to do it quickly. We don't have time to create the benchmark because open source benchmark, they are useless in the most tasks in real life. Yeah. But sometimes, if we understand that the project is long, yeah, and we don't know, we still don't have the data, yeah, we have to create it from the scratch. We create the benchmarks ourselves. For example, in my team, we're doing it right now for the 5th month already. We are labeling it. And also, it's quite often to create own benchmarks for creating assistance. And in my previous company where I worked, we were developing the smart assistant, something like Alisa. Yeah, and we were creating the benchmark for several years. We were collecting the data, labeling them, creating the texts ourselves. We had authors that wrote the text because you need to have the specific character of your assistant, so I have to create it. Yeah, but usually the tasks are smaller and the benchmark is too expensive to create. So we just collect the real life data and label it and then just use it.
Okay, yeah. Thank you so
Thank
much.
I will add a little bit. I guess the correct way of interpretation the thesis of that benchmarks are not like good or it's inappropriate. The correct way of interpretation is that not it's made bad, but it's general purposed, and because of its general purpose, it's not suitable like 100% and even 50% for your task. So benchmarks are good when it's fitted to your task, and that's what Dasha told about. That in tasks like in big projects, for example, like chatbots or assistants and copilots, it's worth to create it by yourself for your own.
Okay, thank you so much.
Thank you. More questions?
Any more questions?
I guess that's it. Thank you, guys.